Thank you all. Good afternoon, everyone, and welcome to Barcelona for those who come from abroad, and welcome back all of you who are from Barcelona. Let's talk a little bit about React PHP and Symfony today. First of all, a little bit about me. As Mark said, my name is Albert Casademont. I'm a software engineer at Ulabox. Ulabox is an online supermarket, a Spanish online supermarket, working there for the past 5 years now. My Twitter, Casademont. I'm finishing my MBA. This is quite a new thing for a software engineer to go into the business side. That's why the smile is there. It's been interesting. We can talk about that if you want later on. And I recommend you at some point of your career to, if you are interested, of course, in the business side of a company, go and make an MBA and get rid of programming for 1 year, something like that. And of course, this talk is about performance, and I'm really obsessed about performance. My colleagues at Ulabox know about that already, and that I'm really, always looking at how to shave 1 extra millisecond from the website requests. So as I said, this talk is about performance. The quest for the maximum achievable performance when using PHP in our environments. It's been said a lot of times, PHP is slow, PHP is crap, blah, blah, blah. OK, it's not that slow. Can be faster, of course, but we'll take a look at it a little bit later. So this talk is about performance, and how can we achieve this theoretical maximum performance using React, PHP, and Symfony. OK? So first of all, let me walk you through a little bit of how PHP request is processed from the beginning, from the point when you execute a PHP file in your console or in a PHP-PM request. It begins with the parsing. As you know, PHP is a scripting language, so it's written, as the name implies, in PHP. And of course, the first step is to parse these files. After the parsing is done, and if there are no syntax errors, it will build an AST, an abstract syntax tree, which is like a tree structure of all the code in your program. And then it can start perform some optimizations on that code. After these optimizations are done, it's compiled to kind of a bytecode. It looks like an assembler code, kind of. And then, of course, after this is done, it's time for the execution. All these 4 steps combined, they are pretty slow. I mean, that's what we used to do in the beginning. Of course, PHP scripts in the beginning were pretty simple, and it worked quite well. Processing a form. When we started doing PHP, intermixing HTML, PHP in 1 file, you remember that. You've been there. But things have grown quite a little bit, and now we are talking about fully fledged applications in PHP, and this model it's not longer usable. It takes a really long time to do all these 4 steps in each and every request. So then came Opcache, before that APC to the rescue. And what still does Opcache and APC? Basically, these 3 steps are reused in every request. So the bytecode is cached, and in each and every request, this bytecode only needs to be executed. This meant a huge step in the performance increase of PHP scripts. I'm sure everybody here is using Opcache, right? At least, please. Yeah? No? Everybody's using it? No? Come on, don't be shy. No? You should, really. Set it up now, please. I'll go down on my knees if necessary. This will be a huge improvement for your websites, for your scripts, and it's a really simple step. Just install Opcache. Out of the box, it works. Of course, it can be optimized, fine-tuned to achieve the maximum performance, but just as it is, drop the APC, drop the Opcache. Opcache is for PHP 5.5 and onwards. APC for PHP 5.3 and 5.4. So really, do it. It will change your life quite a bit. But as I said before, I'm obsessed with performance. This was not enough. So we come back to the execution step. We got rid of these 3 steps. Fine. Let's try to optimize the 4th step. That's when PHP 7 came here. PHP 7 came last year. This January was officially released. And that meant a huge increase in the execution performance. Get rid of the Opcache. We're talking about the execution phase. It almost doubled the performance of PHP. This was a tweet that I did in February, back when we installed PHP 7 in production servers at Box. And as you can see, the drop is pretty dramatic, from about 50, 60 milliseconds per request for about 30, 35 peaks of 40. So that's just by installing PHP 7. Of course, PHP 7 comes with its quirks and tricks, especially if you are using extensions. The extensions were not backwards compatible, so all the extension maintainers had to basically redo from scratch their extensions. That has slowed the phase of the growth of PHP 7 adoption. But we're getting there. Most extensions are now compiled for the PHP 7, and I can safely recommend, please, to upgrade PHP 7. It will be, again, a huge improvement on your websites, just by installing PHP 7, OK? So these are the first 2 steps. It doesn't make sense to start talking about React, PHP, blah, 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 until you get up to that point when you are hitting the PHP limit. So if you install PHP 7, Opcache, optimize it, blah, 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 you almost reach that limit. And then, one day, you wonder, yeah, can we do about it? Can we go further? Is this like all? Have to wait till the PHP guys, they start doing GIT, they are doing some nice stuff for PHP 7.1 and onwards. But, can we do something about it now? This is us. This is a screenshot I took using New Relic that we use in our production servers. This is the front page of eulabox.com. As you can see, this is the light blue is the PHP time. All the colored bars, sorry, not bars, are in and out operations. MySQL, Redis, some other things, Solar. There's a lot of stuff. So obviously, you cannot get rid of this. I mean, that's another talk, how you can minimize all the requests. But we are going to focus on this light blue part. What can we do about it? So as you can see, this takes an average about 40 milliseconds, which is not bad. I mean, 40 milliseconds for rendering a web page like Eulabox. I mean, if you type it now, it goes pretty well. And you could stop here, of course. This is fast enough for our needs. I mean, you don't even notice if I get it to 30 or 20. But, I like R&D, I like exploring. Thank God my CTO is not really picky on these things, and he lets me, dig a little bit about it and explore other possibilities. So I was wondering, what can we do about it? 40 milliseconds is not fast enough for me. I want to go further. So then I say, we need other debugging tools rather than New Relic. New Relic is nice, but doesn't provide you with this fine-grained control. I'm not sponsored by any means by Blackfire. I know that they are here. But it's a really nice tool. When you get to these levels of trying to dig what's going on, it's really useful. So this is a screenshot of Blackfire we took like 1 month ago, something like that, it's our index product. As you can see, there's some stuff here. This is Redis. We already changed this for the Redis PHP extensions and not the pRedis bundle, blah, blah, blah. So we did a lot of things. But then you wonder, look here with me, that the things that waste most of the time is Composer. Not Composer, Composer update, this like takes forever, but the actual including of all the classes, the auto-loading of all the classes. And of course, if you're using Symfony, I forgot to mention maybe, but we are using the full Symfony stack here at EULABox. There's the modular composer, dependency injection, blah, 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 blah. So you wonder, we have to do that in every single request? I mean, most of the time, all these files are the same. We're including the same files over and over again. Controllers, models, services, commands, command handlers, blah, blah, blah. So you think about, all this loading is really wasted in every request. It fires up all these things. It loads everything into memory. You process the request, as you saw, in 30 milliseconds, and then everything is wiped out. Everything is gone. And you wonder, there must be some way of reusing these CPU, wasted CPU for subsequent requests, for the next request. So again, we come back to the execution phase. And all I was talking about was this initialization phase, this memory allocation, all this stuff that needs to become on the stack of your computer before it can execute the really useful logic. As I said, composer dependency injection. So there's only thing useful here, which is the black thing. This initialization, this is something that we must get rid of it. So as I said, we're wasting a lot of resources. Can we do something about it? The answer is yes. But what else? What's there? So I started digging around, and it came to me, like, Googling here and there, this ReactPHP project plus the PHP Process Manager project. What's this thing? What's ReactPHP? It's based on the reactor pattern, an event loop, which is it's a little bit like Node.js. I'm not trying to build Node.js into PHP, but the idea is pretty similar. What's going on here? PHP, command line PHP process goes up. It opens up a port, and it starts getting HTTP requests. This process parses these HTTP requests and feeds them into our Symfony application, all in the same single process. We don't waste that. And this acts, as I said, as an HTTP server. The nice thing about this single request, as you know, if you stay on the same request, the memory persists in between requests. There's these globals, these loaded classes, this allocated memory that is persisted in between requests. That's the nice thing about ReactPHP. Of course, it comes with some caveats. We'll talk about those a little bit in the end. But this is the thing. You fire up a command line process that opens a port. You connect with your Nginx, your web server of choice, and you start feeding requests directly to this single PHP. Of course, you can open up more processes like PHP FPM workers. You can do that. But in the beginning, you only need one, and it will reuse the same memory all over and over again. Of course, as I said, there are some caveats. We'll talk a little bit about those later. The first and most important one is that PHP is not really ready for that. So there are some memory leaks. There are some things that the memory keeps growing. That's why we kill the worker. OK. That's why we kill the worker after several requests in order to stop these memory leaks. I will talk about a little bit that later. And PHP-PM, this is a project on top of ReactPHP that acts as a process manager for all these ReactPHP processes. Sorry. It's also written in plain PHP. Maybe I forgot to mention here. It's written in plain PHP. That's really nice for us, because when you talk about PHP FPM, it's like a black box for us. Unless you really know hard code C. It's complicated stuff when you start digging into the C code of PHP. But this is written in plain PHP. You can read it. You can understand it. It's not simple PHP. It has a lot of in and out forks. But it's written in plain PHP, which is nice. And as I said, it's much like PHP FPM. So you have a bunch of workers that you can control, and the Nginx attacks one of your processes, and then that process is the one who divides the workload in one of the other processes that the ReactPHP processes that you got. So that's it. I mean, and you ask, that comes the tricky part. I want to show you how this works. I mean, I'm going to go back there, and hopefully fingers crossed that this will work. So here we are. As you see, not working. This is the Nginx. I mean, if the PHP FPM is stopped, the PHP-PM are stopped. Now I'm going to fire up and see how it goes. This test is going to use the real EuLaBox website, the development version of it. Okay? So let's come here, and I'll fire up some processes here. As you can see, this is really simple. It's just a PHP process that you fire up. And as you can see, it boots the Symfony HTTP kernel. You can see a lot of variables, the environment that you're using. This PHP-PM also can be used as a static file server in case for, I don't know, development purposes. Don't use that in production directly in front of your customers, please. As you can see, it's bootstrapping Symfony. It has also support for Laravel, I think, and Drupal. So, but Symfony, the Symfony kernel merging is the one that's most developed. So I fired up only one worker, as you can see, starting on port 5501. And now I can go to my Nginx and start feeding requests to. Now it's when the tricky part comes. It should work. Yeah, it works. And as you can see, this is EuLaBox website, as you can see, and I can navigate. At some point, probably it will hang up. It's not production ready, so there are still some bugs here and there. So, but it works pretty well. And you can see, it's working. And it goes pretty fast. And the nice thing here, if I go back, you can see all the requests coming up here. So as I said, this is a PHP process. It's the same PHP process that started. It's there. And of course, if I can kill it at any point I want. And as you can see, it will fire up some deprecated notices that I have in Symfony. I'll get rid of those at one point in time, I guess. Cool. So this is working. Let's go back to the presentation. So here comes the question. As you remember, we were talking about the quest for performance. We are looking for the maximum performance. So this is nice, but does it really make a change? Let's dig a little bit into it. I did some tests yesterday. I fired up one virtual box with a single core, 1 GB of RAM, using the EuLaBox website in production mode. So the best settings I can achieve, the fastest, no Symfony debug, no Symfony toolbar. And I compared, of course, PHP FPM, the classical setup that a lot of people is using these days. Opcache, of course, at the maximum settings. This is one of the tricky things that everybody asks when you see PHP performance graphs. It's loaded with the best settings I could possibly work out for a PHP FPM 5 workers. And again, comparing to PHP-PM, the name it's a little bit similar. There's no Opcache need here. Why? Of course, the first request will need to do all the parsing, all the AST thing, all the bytecode, but it's the same process all over and over again, so there's no need for Opcache. So you get rid of the Opcache using PHP-PM, which is, one extra layer that you don't need, which is nice. So you don't need the Opcache to perform really well on PHP-PM. So here are the results. Before that, you're already seeing that. Mark, he's the creator of PHP-PM. He claims that his numbers are like much more impressive. I couldn't find those numbers. Still, this was the EuLaBox website. As you remember, it was around 35, almost 40 milliseconds. This is using PHP FPM. As you can see, using React, it goes to 23, 24. again, we're talking about 30 to 20. The difference is not noticeable, but in percentage, it's quite impressive. And again, in requests per second, PHP FPM using this single core, it could process up to 45 requests per second, and using React PHP, it could process up to almost 78, 79 requests per second. So again, pretty impressive for, you know, I mean, PHP FPM with PHP 7, everything worked and done. Wow, such a nice increase. We're talking about going 35 to 40% increase in performance just by installing PHP-PM. But as I said, this comes with some caveats. This is not, you know, let's install PHP-PM in production servers right now. It's not really ready. You have to take care of quite a lot of things. Remember, everything is global now. If you use a global variable out of, you know, a class scope, it will persist one request. For again, if you want to test a simple, you know, typical counter in a website, you don't have to persist it in memory anymore. You only have one worker. Just set up a global variable, and all the requests, you keep increasing that global variable and reading it. It will increase the counter throughout all the requests. You don't need to persist it. It will be on the same memory process all over and over again. This sounds cool, but this can lead up to some weird bugs that we'll talk a little bit. Debugging becomes weird. As I told you, everything has to go throughout this PHP process. It doesn't go directly to the engine server. We were used to, you know, bar dump, echo, whatever, and it will come up in our screens. This is not the case anymore. When you just bar dump or echo, it goes to the console. It doesn't go to the browser. And of course, this is the interesting thing. If you come back here with me, let's try some nice stuff here. This is already set up, I guess. And have here, this is the index controller we have. You know, you debug something, echo, full. And you just do this. You're used to this. Everyone does this from time to time. It's OK. It's OK. Right, you've done it. Just save this. Let me fire up the process again. So everything was working. But then you put a die now. What's going to happen? It will crash the whole PHP. It's not working. Well, it will work here. You killed the process. And of course, remember, you're using one process for all the requests, so you actually killed the server. You have to be careful with that, again. You know, there's quite a lot of tricks here and there that you have to be aware of when you go to this kind of development. It's a little bit of a shift paradigm of what you were used to do before. I put that in red because I guess that most of you use Doctrine in your Symfony projects. You really have to be careful with that. As you know, Doctrine is a data mapper. Benjamin is here somewhere. He knows about that stuff. So basically, what you're using with Doctrine is you're loading your entities from your database, and you're actually populating these entities, and they persist in memory. What happened before? The request was really fast, so it actually didn't matter. It fired up all the queries, blah, blah, blah. You did all your work, flush, goes to DB, and you kill everything, next request, again, queries. But the entities persist throughout the request. This can lead to some really confusing bugs, especially when if you only have one process, one worker, it's OK because all the requests will go to the same worker. Fine, no problem. But what about if you have 5 requests? It will start, you know, drifting. One entity will persist in maybe one state, another entity. The same entity will start being, you know, not in sync with the database. It's really tricky when it comes to doctrine. So my advice, if you're starting with these, just flush the entity manager. You clear the entity manager at the end of every PHP-PM request. Of course, you are losing some performance here, and I'm sure that you can really optimize. Maybe you can keep the entities in memory and, you know, develop some sort of thing that it keeps tracks all the changes in the entities and can, you know, repopulate entities from the database in other workers. Some stuff can be done, but remember that this is now a global state. Things are persisted throughout requests. So be careful with doctrine. As we talked before, memory leaks, PHP is not ready for that. There are quite a lot of memory leaks. So if you keep this process up, the process I just launched, like forever, it will start growing the memory all over more and more memory. So after some point, PHP-PM just kills the process and starts again to get rid of these memory leaks. By default, it's 500. Of course, you can fine-tune it. And you didn't see any crashes, thank God, but still buggy at some point, especially with Symfony in development mode. In production mode, goes really well, but once you start putting all the monologue things, toolbars, blah, 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 it crashes from time to time. So still not production ready, still buggy, needs some love. Of course, this is a GitHub open project. I encourage you to help Mark, which is the guy who leads PHP-PM. So still work to do. It opens a whole new async world. We didn't talk about that. We just put a Symfony, the Symfony we were using. We're done. But this opens up a whole new world of doing things async. What about if I can, query my database, but in the same process, I can open up another port and process another HTTP request while I am waiting for the database query to come back, and then I can resume what I'm doing. So again, with Node.js, if you've developed with Node.js or JavaScript, it opens a new whole world of callbacks, which is a tricky thing in PHP, but this kind of setup allows these things. I haven't digged into it yet, but it opens this whole new world. As I saw, this would ideally be our PHP server of choice. Why would you use PHP FPM? This is faster. It's written in PHP, which is nice. You can understand. Everybody can, fine-tune this PHP PM process manager. Not PHP FPM. This is written in C, which is, it's kind of a black box. You just fire up and it works. So this is what I would like to, that this should become the PHP server of choice. Again, still needs some love. But I think that we will get there at some point. So again, some resources that you can check. The project is a little bit abandoned right now. I think it needs really some love. So if you like, just for exploring, you can. It's really easy to set up for a Symfony project. It's not really complicated, so you can try it. And I encourage you to try it. And, start, shaving off those milliseconds and, get fancy of those. As I said, it's not really in absolute values, it's not a huge increase when you are coming from 30 milliseconds per request up to 22. It's not that much. But in percentage, it's, like, huge. So, and just with some fine-tuning. So this is going to be the next big thing, I think, in PHP. And hopefully, it will be. So if you have any questions, I'll be happy to try answer them. And if not, thank you very much. Gracias. And of course, at Eulabox, and I guess that like everyone else in Barcelona, we are hiring. So if you would like to dive into these kind of things and you'd like to, it's not that what I do every day, let's be honest. I wish I would, but this is nice to do from time to time. Thank you very much for your time. And again, if you have any questions, I'm here. Thanks. Yeah. Let's see.
Hello.
Hello.
I have two questions.
Yeah.
First, when to kill the worker? So you kill it because not to have memory leak. How do you know that the worker is not processing user request at that moment when you kill it?
Oh, because as I said, the PHP-PM fires up like a controller process that stays not processing requests, but just managing all the other requests. And he's the one that checks when some process is failing, and it fires up another process to replace it. So there's like a bunch of ReactPHP workers, and there's this controller that rules them all and keeps track of their state. And if some of them dies, it just fires up another one. If I remove that die that I did before, it will work again. I don't have to, reboot all the process. This manager keeps track of everything and, it's trying to get everything ready.
Okay, nice. Second question about global variables. So they're shared between all workers, right?
Yeah.
So counter that you mentioned, whenever you increase it, it's shared between all of them. That's the question.
If you're used to developing applications with Symfony, you already got used to developing within a class, within a request, within a response. So we are used to that. But if not, just open up a global variable in PHP. It will go to the global namespace. And yeah, it will be there. For the next request, it will come to the next. You can read it and write it again. So it's like it's weird in the beginning because it's, well, shit, this shouldn't be happening. We use sessions for storing counters before or even writing to this. But now, it's dangerous, but at the same time, it can open some possibilities for using global variable. And of course, this is much faster than using sessions. You have a global variable ready for you to use. So yeah.
OK, so if all workers die, what happens with the counter, with variable?
Of course, it dies also.
OK, so it's in memory.
Yeah.
Thank you.
That's the nice thing, but of course, the moment the worker dies, that counter dies. And remember that you normally have like 5 different workers. Each of every one of them will have their own counter. They share its own memory within the process memory space, like in Linux, whatever. So yeah. It's nice, but you have to be aware of those, especially when using Doctrine, as I said.
OK, thanks.
Welcome. Any more questions? There's one there. Whatever.
I have just one question about the debugging. I saw you did something really.
Oh yeah, you use bar dump. It won't.
Yeah. Have you tried with Xdebug how it works?
It didn't because I still have some problems with Xdebug in PHP 7. I don't know. It's not really working for me right now. So I haven't really tried Xdebug with PHP-PM. But yeah, of course, this is the way. It should be the way of debugging. I don't use Xdebug that much. But it should be the preferred choice of debugging. And of course, Xdebug would work fine. You would use Xdebug in the console, it would stop the process and you would see all the variables there. And of course, you can use error log. If you use error log, you remember that in normal PHP FPN process, it will go to the error log file. Here, if you use the error log function, you will see the message printed in the console. So it doesn't go to a file, it goes to the console. So you have to be aware of those things. That you cannot rely on the standard output, standard error for using. That's a paradigm shift of what we were used to using PHP. So yeah.
Thanks a lot.
Welcome. Any other questions? Here? Someone said here? No? We're done? OK. Thank you very much again.